Hi there, I'm Scott from Thriving in Place, and I'm going to talk to you today about how we design our cities and how some of those choices impact the amount of driving and transportation emissions that result from the cities that we live in. So, we're going to start off talking about some data, and then we're going to look at some specific examples to kind of help bring it to life a bit. Looking at this graph here, there's a lot going on, but don't worry, we're going to break it down. Each of these points is a city somewhere in the world, and there's 10,495 of them, almost every city. We couldn't include all because of data quality, but it's almost every city in the world. And then they're arranged on this is the x-axis here. So this is where population is, and you can see it goes up in a log scale. So there's 100,000 here, but there's a million here. But the further over to the right you go, the more population is each of these centers, and it goes up on a log scale so that we can put all of the data on the same graph. And on the y-axis, we have density. So this is more people per square kilometer. And so that's shown here. This is 1,000 people per square kilometer. This is 10,000 people per square kilometer. 10,000 people per square kilometer is about 100 people per hectare for people that are more used to those units. But the higher up you go on the graph, the more dense the cities are. And so down here is some of the lowest density cities in the world. And then in terms of size of the points, that's related to the total vehicle kilometers traveled in the entire settlement. So not per person, the entire settlement. And as you see, as you go to the right, the points tend to be bigger. And as you go down the graph, they also tend to be bigger. And then lastly, we have the color of the points, which is the tons of CO2 equivalent per person per year. And so that's represented by this color square here. You can see that there's three tones. So at the white tone, that means the city emits about 2 tons per person per year. And 2 tons per person per year is a good budget for the total amount of carbon emissions that we should be emitting. And so if we're emitting just 2 for only transportation, that's probably too much. So if you're in the orange zone, that's high. And the blue zone here at about light blue, you're getting around 1 ton, and then below that, you're getting less than 1 ton in the darker blue areas. So what we can see here is that this graph kind of shows the pattern about how population and density relate to these two different variables. So emissions from transportation and total amount of driving. So now that we kind of have an understanding of what this graph is showing, and you get some sense about where the different colors are, let's look at some specific examples. So here is a street view from a sort of typical residential area in Hong Kong called the Mid-Levels neighborhood. And so, as many of you have probably seen pictures, or if some of you have been to Hong Kong, you know that there's lots of high rises. People live in fairly high density residences there. And now here's another street view from the Oost neighborhood. I apologize if I'm pronouncing that incorrectly, from Amsterdam. And you can see that it is 4-story townhouses, stacked townhouses along a more narrow street. And these sorts of neighborhoods are quite common in that part of the world and sort of the northern European Nordic countries. And then here is a street view from a fairly typical neighborhood in Los Angeles, the Encino neighborhood. And you can see that there's some wider streets and fairly spread out housing. So now, given that what we were just looking at in terms of that graph that showed all the different cities in the world and the different colors and the relationship with density, I was want you to take a moment to just think about where you think each of these cities exists on that graph. So what color do you think Hong Kong is? What color do you think Amsterdam is? And what color do you think Los Angeles is? So here are the answers here. You can see that Los Angeles is the large orange dot down here in the right-hand corner. It's it is the largest autocentric city in the world at 3.9 tons per person per year in transportation. Amsterdam is a light blue at 0.98 tons per person per year. And then Hong Kong is a dark blue at 0.25 tons per person per year. And so I just wanted to give those examples to kind of highlight the fact that there is, we have options for reducing our transportation emissions. And we need some big buildings, especially near transit, especially downtown and some of those really high destination rich areas for sure. But in a lot of parts of the city, what we actually need and could use is sort of this, what we call missing middle housing. These, 4 stories in the middle of neighborhoods, and then maybe on some of the bigger streets, we go up to 6. And this sort of low rise uh, neighborhood style gets rid of most of the emissions. I mean, you could see Los Angeles at almost 4 tons per person per year. In Amsterdam, it's all the way down to one, which is it's a nice little sweet spot. You have to go way higher and way denser to get the any additional benefits from density. So there is sort of this sweet spot right in the middle that if we can make that easier to build, right now we have such strict land use and building code regulations on those missing middle housing. We just can't build them. It's too difficult. It's too expensive. And if we made it easier to build those buildings, we could reduce home prices and we could cut our emissions all while living in some pretty darn nice neighborhoods. So it's something to be thinking about coming up in future municipal elections, provincial or state elections, depending on where you live. That we should be asking for some changes to the rules that we have so that we can build some of these buildings. Thank you very much for your time, and I hope you learned something. And feel free to drop us a line at thrivinginplace.info. Thank you.